My name is Mike Davis. I'm with the City Colleges of Chicago. I'd like to welcome you all here to our presentation on the adventures in open source hardware and software and the partnership that came out of it. And I'd like to introduce the partners that I have with me.
I'm Jamila Jaffrey. I advise on STEM partnerships for After School Matters.
I'm Shereen Elmett, the Leadership Grant Program Manager with Primary School Matters.
And we're all here in Chicago. You guys too. Just actually, while referencing you guys, how many of you here are educators? I mean, your primary job is to teach students. Okay, do we have administrators here as well? A few? Some of you raised your hands twice, it looked like. Outside of educators and administrators, industry representatives? One, my wife. Did I miss any large groups of people? Okay, good. So it's always good for us to know who we're speaking with. The partnership that we're going to be talking about came on the heels of something that took place about 6 years ago. On the left, that image right there, maybe a little hard for you to see, but that is the world's largest periodic table of the elements. Made that in downtown Chicago in 2006. And the way we funded that project, it cost us $76,000 to fund that project. The way we did it is we sold different funding opportunities for each element. So if you were interested in sponsoring an element, we charged you $3,000 or $5,000 for two, and you could sponsor an element. We wrote up in the Chicago Sun-Times as to why you sponsored that element. So fast forward 7 years, it turns out that there was a little bit of money left in the account that had turned that over, about $5,000, and they asked me, could you spend this on something like that periodic table again? I said, there's no way I can afford the periodic table on $5,000, but I think we can think of something else to do. So what I did is I reached out to some people that I was familiar with and bought 60 Raspberry Pi computers and gave them away to educators at an event that we organized at Google. It was literally, here's something that I know is really hot. I don't know what it does. I don't know what you want to use it for, but I want to give it to you, and I want you to come and have some food and drink with me. And really, that was the criteria for that event. We learned a lot since that event, but our partnering organizations really wanted to make some relevant training experiences. So we just had some basic goals as we came together. That original event was City Colleges of Chicago and Element 14. We were the two major players in that group. And we literally met a week before that event was to take place through a mutual friend who said, you guys should really know each other. Our goal was to provide teachers and out-of-school time, you'll hear that phrase a lot, out-of-school time STEM providers with a new resource, to give them the ability to leverage the resources that each group had, and to really insert some creative STEM and computer science activities into out-of-school time. We've done this. That first event was on July 18th, and that took place at Google's headquarters here in Chicago, and we gave away 60 RPIs to 90 attendees. We had more people coming than I could give things away to. On December 12th, for the Hour of Code, we gave away another 33 Pis and some Arduinos, and that was at the Illinois Institute of Technology. On February 8th, we did a follow-up to that event. People who got Pis that first time were to come back a second time, and we're going to work on another project. And then since May of 2014, Element 14 has been instrumental in us giving away another 60 Raspberry Pis, and this was for people who joined the Element 14 online community, the STEM Academy. We'll be talking a little more about that in a bit. But let's look at that Hour of Code, that time where we had people come and then come again. That was one of the innovations that we put on our original giveaway. It's not enough to just give something away and say, here, go, and I hope you have fun with it. We wanted people to unbox them, open them up, plug them in, and then try and learn, okay, what can this do? What am I going to have questions with? Go home, try a few things, come back, and let's see what we can do then. So the Arduino training side, the people that did that, they worked with LEDs, they made them light up, blink at different rates, fade in, fade out, all the wonderful things that sort of beginning Arduino projects look like. And they also made a theremin, so it's something that they could interact with. It was really cool. Roughly 15 of our teachers attended this one. On the Raspberry Pi side, they learned how to manipulate Minecraft. There's an open source version of Minecraft for the Raspberry Pi called Pi Minecraft, or PiCraft. Apparently that's a game. I don't know what you do in Minecraft, but it seems to be pretty cool. And we also went through how to make an internet radio, and I'll showcase that in a minute. And basically what that does is that streams radio stations. Let me introduce you to the Raspberry Pi, and I think I should be able to pass one around, since the one I have plugged in right now is probably having a hard time getting on the network. It is a $35 computer. It has it has an ARM processor and a Linux operating system. You're able to get online either through a wireless connection or through the Ethernet. The Raspberry Pi Model B Plus, which came out a week ago, so I had to update this slide last week, has now 4 USB ports on it, which is up from 2. There's an HDMI output, so this can plug into anything that will accept an HDMI, and also has audio output and some input-output pins. So I'm going to pass one around for you guys to see.
You said $35.
$35 is what I said, for sure. So what can this do? One of the things that this can do is it acts like a computer. The great thing about a $35 computer is I can dedicate this machine to doing something and really only invest $35 in it doing that. So one of the things I wanted to do is I wanted to experience radio the same way that I would in my car, where if I hit preset 1, hey, that's a good song, but not as good as what's on preset 2, and just go through. My wife's favorite radio station is Scan. It just goes through all of them, okay? Internet radio stations aren't quite the same. I have to go to a browser, go to a URL, and say, okay, I like this one. No, actually, I want to go see what's going on in St. Louis. I'll close that. I'll go to this other one. I'll open this one. It's a little more laborious. I actually want a box that's going to sit on my desk at work, and I can just hit one button and go on to the next one. So what we taught teachers to do is they would download Music Player Daemon, download a client for that. I taught them how to find streams, load them up into that, and then start clicking through them. So actually, if you do this on your phone, you can actually go to this on your phone or whatever computer you're on. You can go to this website. This is the address for the Pi. You go to /music. That will actually take you to the interface for it. Now, right now, it's having a hard time actually playing out music. I'm not sure what that's all about. But this right now is live, and you can start and stop and change the radio stations through a guided user interface, which is great. That means that now we have a computer that's doing something, and I have a way to interact with it. And this was a skill that we could have teachers pick up in about an hour. A second thing that was relatively easy to do is to teach you how to collect data. So what we're able to do here is, this is a cooling curve. So this is a very hot solution of sodium acetate that's been cooling overnight. And what I'm going to do now is I'm going to drop a crystal in it. Are you guys familiar with the supersaturated solution demonstration? You have something that has just so much solute dissolved into it that it can't take anymore. So if I was going to add anything else to it, it would cause everything else to come out of solution. So what I'm going to do now is show you what that looks like. And before I do, what do you think is going to happen to that temperature? I'm going to turn a liquid into a solid. I'm going to go up, go down, go down, and 2 ups. All right, let's see. So about 4 seconds in, temperature spikes right here. Goes up from about 20 degrees down the order of 28. This is going from clear to being white. The crystal that forms is white. And this is actually a very exothermic reaction. And if this goes all the way to the 37 seconds that I captured here, it goes up again. Okay, so in a very short period of time, you see a large temperature increase, and it will top out, and then it'll start to cool again. So this is really cool. In a traditional science class, about 45 minutes long, what you would do is you would set up your experiment, you'd take a quick data point, and then you would clean up your experiment. Very little science is actually conducted in that way. So being able to collect temperatures over long periods of time is something I got very excited about. I'm looking for a way that we can give this to educators, and this is the content that I was really excited about. I'm going to introduce Jamila Jaffrey from After School Matters. She's going to talk about, yes, we have a great tool. Where can this tool be applied, and what's the landscape for us applying this tool?
Thanks, Mike.
Yeah, let's go back. Absolutely. But of course, as soon as I unplug that website will go away. Okay?
Do it now, hurry. So Mike was, my name is Jamila, I'm with After School Matters, as Mike said, and as Mike was mentioning, there's a lot of work that we were doing with educators. So I'm former high school science teacher. So when we think about educators, we think a lot about the in-school science world, and when we think about partnerships with educational institutions, we're often thinking about schools, which are obviously really, really important. But the field that I'm now in is the out-of-school time world, which is called OST. And you may know the term informal, so informal science education, that's a term that comes up a lot. And that sort of world, that informal world, has kind of collected together and organized and now calls itself the out-of-school time community. It's really, really important out-of-school time because it turns out that, over the last decades, lots of people have been doing a lot of great research about out-of-school time and why it's really, really important for youth, that particular block of period. So that means before school, after school, summer, weekends, just everything that you're doing that's not in the school time. Turns out that when you do a little bit of math and you're sort of figuring things out, that young people are actually only spending 20% of their waking hours in a classroom. So the question is, well, what's happening the other 80% of the time? You can use a deficit model and say, oh, they're getting in trouble, right? Or they're bad things that are happening. Or what the out-of-school time community actually does is use sort of a positive model, which is that this is a time when young people are working with mentors. This is the time when young people are doing the things that they're passionate about. This is the time when young people are doing sports. It's a time when young people are exploring things that are actually of interest to them. They're often working in teams and they're often collaborating. So for the out-of-school time community, all of us that are in the after-school world and in the summer world and in the weekend world, that's really important. It's an opportunity for us to think about how can we reach an audience that may not be reached in the in-school world. It's a social justice issue. And so out-of-school time is the context for this partnership. So STEM and out-of-school time, that's a whole other, so now we're sort of honing in on what does STEM look like. In the city of Chicago in 2011, we launched, the Chicago STEM Pathways Cooperative launched. And basically it was a group of stakeholders who came together. They were all interested in youth development and in the opportunities that Chicago youth have to explore science, technology, engineering, and math in the out-of-school time world. And so they came together and they decided, with some funding from Noyce Foundation and Chicago Foundation for Women, that they were going to do a comprehensive community-based survey of all the K through 12 opportunities that are out there in the city of Chicago. This is really, really important because it was also we were talking about open data before in the large group setting, and so this is all this data is open and you can actually check it out at stemchicago.wordpress.com down there. So here's the big thing that we learned in the city of Chicago, and even though this is from 2011 and some things have changed, I suspect that that the big picture is still the same. Big things. 2,000 STEM OST programs are happening in the city of Chicago. That's huge. 2,000. That's a lot of programs, okay? Most of them are reaching middle school youth. They're generally available in most neighborhoods, but not all, so that's really important. This is really important for computer science and girls, right? More programs serve more girls than boys, which is really interesting. Latinos are still underrepresented in out-of-school time when you compare them to their the actual population in Chicago public schools. The out-of-school time programs in general are more likely to target low-income students and students with existing interest in STEM. So that's important too, what's happening to all the young people that are not interested in STEM. And libraries, museums, and universities are underutilized as spaces. So this is huge. So because of this, we sort of found some gaps. And at After School Matters, we're the largest out-of-school time provider for Chicago high school teens. So for us, this data is really, really important. We actually provided a bunch of the data for this report, but we were really, really interested in what we figured out here because through this, we were able to really drive a partnership using data. And so what we ended up doing with After School Matters and then with all of the partners, we all got together and we said, we all want to reach underrepresented youth. We all have this shared agenda. We all are sharing the same data now, right? We can all come together with our different resources and our different missions and the things that we want to accomplish, but there's data that's pulling us together so that, we sort of have this shared idea of what we want to do. We also knew that we wanted to focus on engineering because if you go to the report, less than 1% of those STEM OST programs were in engineering. So out of the 2,000 programs, less than 1% of them were engineering. So we knew computer science was going to be important for us and engineering in general. We knew that museums and institutions like universities were underutilized, so we knew that we wanted to leverage STEM-rich partners. And a big thing is we wanted to support educators. We're in the out-of-school time world. Other people are in the in-school world. We wanted to make sure we were reaching both audiences. Anything else? So, voila, in November, we learned about this event called Hour of Code, which was a national event. You may have heard of this. The Computer Science Education Week put this out. And so this was coming up in December. Chicago STEM Pathways Cooperative, we had a few meetings in the summer and in the early fall. Partnership was on our mind, and this provided the opportunity to really come together around a national agenda. And so we let that drive us. Now, Hour of Code is really about young people coding. As I said before, what we really want to do is really think about professional development for educators in the in-school world and out-of-school time world. So really bringing people together from the educational community at large to really talk about computer science and to have them do something engaging, which ended up being around the Raspberry Pis. And here's some artifacts. I know you can't read them. There are 2 slides. But basically, the big idea here is that the educators came together. We sat around tables after all this really great tinkering and making, and we said, what are some challenges? What are some aha moments? What are some things that we still have yet to discover? And what's missing? And so what was really interesting is that at the table, there were museum educators. There were after-school program providers. There were in-school teachers. There were folks that were just, thinking about their own children, actually. And so these folks were coming together and they plotted out what are some challenges and what are some things that they're really looking forward to. And the sort of big idea that I sort of want you to keep in the back of your mind is that it was really a collective effort, not just of in-school teachers, but of a large group of people. And the big sort of things I'll say that came up in these artifacts are time. Just people need time to be able to invest in sort of tinkering and sort of learning about this. Money is an issue, so just as Mike had said that Element 14 was really able to provide all of these resources, and that partnership is really critical for that reason. But that's something to sort of keep in mind as you're thinking about supporting your educators. And another thing that educators were talking about is that their young people weren't just doing things in school, but they were doing things out of school, and that they themselves wanted to partner with one another in order to make things happen. So this thing on the right is actually about one of the educators talking about how they're partnering with the Field Museum, which you wouldn't think about the Field Museum as a place where they're doing a lot of digital learning, but in fact they have an entire digital learning team. So what he was talking about is how he's partnering with them. So this is the kind of stuff that was really, really exciting. Oh, and then here's another one. And now my colleague Jay.
Thanks. As I said, I'm Diane Kibbe, and I am actually the global head of our online community, Element 14 at Newark. I'm not sure if you've heard of our company, Newark Electronics, but just a little bit about us. We are a global distributor of electronic components. So we don't actually make anything, but we distribute over 2 million electronic components from about 4,000 different manufacturers. We are actually based in the UK, so we're based in London, and the name is actually Premier Farnell, but in the US, we're actually known as Newark Electronics, and we've been headquartered in the Chicagoland area for about 60 years. If you look at who our primary customer is, it is the electronic design engineer. So those making the latest in high-tech products from the latest in electronic components. We also sell quite heavily to maintenance and repair engineers and purchasing professionals. But our primary customer is the design engineer. So about 5 years ago, we launched the Element 14 community. It's an online community, element14.com. And the reason we launched it was to bring together electronic engineers, electronic enthusiasts, and educators, and to be able to let them know about new products and technology coming to market. At the same time, we also thought it would provide a place where they could actually collaborate, help each other out, and help each other solve problems. We now have over 250,000, I think it's actually 260 now, registered members from 40 different countries, where probably 40% of it is US, there's another 40% that's Europe, and then 20% is actually from our Asia-Pac region. And really, it's become a very engaged group of customers that are truly talking about new technology coming to market, things like Internet of Things and Raspberry Pi and Arduino. And a lot of times people ask, where did you get the name Element 14? And this is probably the first crowd I've talked to that probably gets it right off the top of your head, because you're familiar with the periodic table of elements. And the 14th element is actually silicon, and silicon is at the heart of all new electronic design going on today. And when we were looking for a name, we wanted to be at the start, the heart of all new electronic design going on for our engineers. So that's where the name came from. Which was a weird coincidence that you had just done the periodic table thing.
Yeah. One quick thing. I'm a participant in the Element 14 online community
I find communities like this really helpful when I have unanswered questions, which are pretty often. And it was one of these questions I put in within a couple of minutes. I had 2 or 3 competing answers, which I guess is not at all unusual for engineers.
Right. When we were going to launch, a lot of people said, "Oh, engineers will never talk on a community. They are not sociable people." But they are extraordinarily sociable, very helpful, and very strongly opinionated. So you will always get an answer, and you'll get a lot of varying opinions. So something really big happened in 2012 that kind of changed the whole face of our community, and that was the launch of the Raspberry Pi from the Raspberry Pi Foundation in the UK. So this small credit card sized computer is $35, and the day that it went live, it was like this phenomena that started. It crashed websites all over the globe. Ours was one of them because at the time we were only one of 2 global distributors authorized to sell the product. And this product was actually developed by the foundation for the sake of developing the next generation of engineers. So it was actually developed to get kids interested in coding and engineering again. So that really, I think made a strong statement with a lot of people. And it was purchased by fathers and mothers and teachers, as well as electronic enthusiasts and DIYers, and then even professional design engineers. There was a lot of debate in our company about whether or not we were just drawing all these hobbyists to our company, but actually over half of them were bought by really talented electronic engineers that were just really interested in this product. So about a year into selling it, we started to really think about what we wanted to do. There's a ton of people at our company that are very passionate about the STEM initiative. And we started thinking about how we could use our community to actually also help develop the next generation of engineers. And we thought we could do this by helping educators use Raspberry Pi and other open source technology like Arduino in the classroom. We've done a lot of surveying, and I think the biggest piece of feedback we got is these products are really cool, but when you open them out of the box, it can be a little bit intimidating. They don't really come with directions. So we thought we could really provide some direction on how to get started and what you could do in the classroom as far as different projects. So this led to a lot of different live events, which Mike talked about. And like I said, Mike said we actually met a week before the Google event and came in and gave him the operating system for a lot of these boards. And it was at that event that we met a ton of educators that were actually really interested in using this, and we started to think, wow, maybe we actually can provide some value here. So shortly after we launched the Raspberry Pi Academy on the community, which soon migrated to the STEM Academy because it's way bigger than Raspberry Pi. There's a lot of other products that you can use to teach engineering and science. And we had already surveyed a lot of our top members in the community, so professional electronics engineers that were very interested in helping people get started with Pi, and especially educators. So like Mike was saying, he can literally post something. We have so many engineers that are already in there just ready to help in any way that they can. We next generated the Raspberry Pi Getting Started video series. So we just kind of developed a 3-part series that kind of shows how to take it out of the box, how to plug it in, the next stage getting the operating system running, and that, that's kind of a good tool just to kind of get started. As well, the Foundation's website also has a lot of good information there. And while the community had a ton of projects, that's one of our big claims to fame, is that we have all of these members uploading the projects that they're doing with Raspberry Pi. A lot of these weren't geared towards the classroom, so a lot of them are like beer makers and things like this. So we really wanted to generate like a whole new group of projects that were really great for the classroom. So that was when we worked with Mike to actually donate 60 more Raspberry Pis to a network that he had, with the agreement that if we give you this, would you please come onto the community and tell them about your experience? Talk about how you're using it in the classroom so that it helps others. And all of this is geared, towards growing the STEM Academy community. Okay. So what's next? We're continuing to build out this STEM Academy area as a resource for educators, whether they're looking for online training, whether they're looking for projects they can use in the classroom, or they're actually needing some expertise, some actual technical help with a problem that they're having. So we're in the middle right now of developing these virtual tech support sessions, and they're really using, Google Plus. Using why am I having a brain dump? The online Google.
Hangout?
God, I do. We do these like every other week, and I just couldn't think. We're Google Hangouts. We use those a lot to get a panel together. They're really cool and a great interactive way to let people talk to others. We also use the traditional WebEx sessions. So we'll be holding a number of sessions where educators actually get on and talk about what they're doing in the classroom. And then we're also going to have these panels where professional design engineers will be there ready to answer questions. So it's kind of like a follow-up to the Getting Started videos. If you get your pie, watch the videos, and you still have questions and you're not sure how to do something, this panel is just kind of an open forum where you can ask any questions that you have. And then, as I told Mike, I'm often reminded that we are not a charity. And so, my team especially, we're very passionate about our community and connecting engineers. We do sell product. So the community makes it very easy once you want to develop a project, for example, that you can buy all the parts that you need from our online store. So for every project, we're developing kind of a bill of materials that says, here's the 6 things you need to get this project going, and then you can kind of link over and buy the products. I have to remind everyone of that. But I think it's going to be a really exciting year because the foundation just launched the B+ board. There's a lot of new things coming out in Arduino, and we're going to continue to build out this area. And I put the URL for it on the previous page. So you can also just go to the Element 14 community, and it's very easy to find the STEM Academy. Thank you. Oh, sorry.
One thing I'd like to point out on this is a screenshot of the STEM Academy when you go to it. By way of sort of introducing the IIT Bonus Scholars, when she comes up, this person right here, John Moosmiller, was a student that worked with us on our very first event. At the time, it was a graduating high school senior who had the audacity to write what to do and what not to do as a computer science teacher, and read this to a room of 90 computer science people who were aspiring to teach computer science teachers. And he was bold and exactly the guy you wanted him as. And he's an ongoing college member of the community. And so this is a great place for all of us to do the interaction.
Okay, how's everyone doing? Still with us? Okay, so I am really excited about the young people that I get to work with every day. These are high school juniors and seniors. We affectionately call them scholars. IIT Bowling Scholars has been around for 3 years, and we work with approximately 100 students per year. This last year, these are our stats from this past year, we worked with over 103. We worked with 103 students. 29 were seniors, 74 were juniors. This is a 2-year commitment when high school students sign on with us. And the process for getting into our program is highly competitive. It's almost like going through a college application process. We interview you multiple times, and we have you fill out an essay, tell us why do you want to be in this program, and what is it that you want to change in your community. And so we're very interested in how young people are thinking about their community and how aware they are of some of the different social issues and environmental issues going on. As you can see, our students come from all over the city and the outlying suburbs. Most of them are CPS students or go to some of the charter schools in the system. If you take a look, 73% come from underrepresented populations that traditionally don't pursue STEM careers, and 57% are female. And another thing that we really look for are first generation college bound students. So how do we work with our young people? Our program model is this. So they sign on with us in the summer. They go through this 4-week intensive academic enrichment program. And as you can see, or maybe you can't see, we have a tiered system. So we have design thinking activities, we have project challenges, serving through STEM, leadership grant project, and ultimately, all of this activity leads to getting them prepared for college and career. And so when we're looking, so the 3 that I want you to really kind of take a look at are the project challenges, serving through STEM, and leadership grant projects. The way that we get young people excited about STEM careers is through hands-on projects. And so each week when they're in our summer program, they're exposed to different kinds of real world challenges. So, for example, we have this summer, we have young people that are working on these 4-hour-long projects to take a look at what's going on with transportation in the city of Chicago and how people are interacting with transportation and what issues do they see around that and how would they solve that problem. So we take them through this methodical process of how would you address this issue, what's the problem here, and how did it become a problem. And then they come up with solutions, possible solutions. So once they get through that project challenge phase, then they move up to something that's a little bit more difficult and challenging. So they work on these projects called Serving Through STEM. And with these projects, they require about 6 days to complete. They work in project teams, and they're utilizing their STEM skills. So they're problem solving, they're trying to figure out how did this issue become an issue, and what are some ways that they can tackle it, and then who does this problem most affect, what community. And some examples of some service through STEM projects that we're doing this summer. On the IIT campus, we have beautiful trees. We have so many trees, and so our students are taking an inventory of the trees, and they're figuring out how much water is being used to water these trees. And so they're taking that and they're keeping a log. So this helps the university because there are some trees that may need to have special care, and so it helps the staff there at IIT know which trees that they need to take out and give extra care to. And then finally, the Leadership Grant Project. This project takes about 10 months to complete, and it's typically our juniors that work on this project. And with this project, the teams figure out an issue that is really close and dear to their heart, and they figure out a way to address that issue. And so, again, they're working on project teams, and they're trying to figure out, okay, what's the best way to approach this problem? Who is it impacting? Why should people care about this project at all? And so we have adults that help support them who are mentors that may be professionals in a variety of different fields that lend some assistance to the teams. And so as you can see, as a result of the young people going through this curriculum, they're really getting the idea of, okay, so if I'm going to pursue a particular career in STEM, these are the skills that I need. And so they're really excited after they finish the program. And this is my first year with them, and so I'm really excited. And we can't wait to see what other projects that they will explore.
Could you share a project or two that the students have chosen?
So right now, during the summer, they have identified some really broad topics. So we have how young people interact with social media, how they're consumers and producers of social media. We also have topics around waste management and how to how to recycle better and use recycling, what are those called? The recycling bins more appropriately. We have a project around education. We have actually two projects on education. One group is looking at education and the dropout rate, and they're trying to decide if they want to tackle at what point should they look at the dropout rate. Is it in high school or is it in middle school? And then we have another education group that's looking at access to STEM careers, or access to math and science resources in elementary school, and how it impacts test scores and grades. And if there is a disparity between certain schools within a same neighborhood. So some really diverse topics, and so right now they're narrowing down the topic and trying to figure out what's the problem and what's the underlying problem and how to address it. And then over the next 9 months, they're going to figure out ways to kind of resolve it, or not resolve it, but some possible solutions, and then make a plan for how to make the public more aware.
So, so as you're hearing, as you just heard from Trinine, and then that sort of the context of out of school time, there are a lot of places, in the city of Chicago where there's a lot of great stuff that's happening. And again, so IIT was such an important partner because, as Trinine just described, they have this great program already in place to support young people in doing really great STEM. And that's all happening in the out of school time world. And so we knew again from the report that STEM-rich institutions like universities were underutilized as places where sort of collaborations and partnerships were happening. So when we came to the table, and IIT was part of the Chicago STEM Pathways Cooperative that was part of designing that study, when we came to the table, we knew that we wanted to partner with IIT because they had the enthusiasm, they had the expertise, they had the resource, the space to be able to partner with them. And so that was really important. And then, so some key, and then some key takeaways to sort of think about as you're doing your own partnerships, whether you're working with universities or you're working with nonprofit organizations or your own city colleges, et cetera, that to think of educators in a very broad sense. Again, as so many hands went up, when you think about education, so many of us are educators. To make sure that lots of people are at the table, people that you wouldn't normally think should be at the table when it comes to education. So an organization like IIT Boeing Scholars should definitely be at the table, but you might not typically think of them if you're thinking about the in-school world, right? After School Matters should be at the table. A small organization that's doing art should be at the table. And I say that because what we learned is that people like to collaborate on these things, and they're bringing a lot of their expertise themselves to bear to make a really fruitful project. So that same idea of sort of having a positive asset model when you're thinking about young people, it's the same thing that we're learning that you need to have when you're doing professional development with educators. So as you're doing your own partnerships and you're thinking about developing your own workshops around Raspberry Pis or Arduinos or any open source hardware and software, to build in mentorship opportunities. There are people that are already in the community, just like as Diane was saying in the online community that Element 14 has, that are already experts, that have been making and tinkering and doing this stuff sort of on their own. So whatever it is that you guys do on your own, providing that opportunity for them to share their own expertise is really critical. And then again, thinking broadly, we didn't just, After School Matters, we not only invited our, like what you think of as our science instructors, we also invited our technology and art instructors. So the people that were at these workshops weren't just doing science. These are people that are doing animation, right? They're people that are doing, there was one person who was teaching a bike program. Everyone's got is really, really excited and interested in this open source hardware and software because it's all about telling a story that's relevant to your community. So inviting those people to come is very exciting. And After School Matters now, one of our art instructors is actually going to be using Arduinos in her program, so we're very excited about that. Sort of the final takeaway that is really important is to have sustained opportunities. So the slide that you had up before that you saw, there were 4 workshops. We, After School Matters, participated in 2 of them. Just as young people need sustained opportunities to really build a relationship with what it is that they're doing, for that experience to be meaningful, to have some people that are mentoring you, same thing goes with professional development. So whatever it is that you do, certainly think about how are you providing sustained opportunities for those people to really explore what it is that they're tinkering with, whether it's Arduinos or Raspberry Pis, and that can happen virtually. Element 14 has got that digital or that online community. That's a way of providing sustained support.
So wrapping it up and taking into conclusions, one of the things Diane mentioned was a beer project. So people bring on lots of things. I actually did use my Raspberry Pi and the temperature idea for it. Basically dropping a thermometer into the 5-gallon batch of beer that I was brewing because I was very curious while I was at a Baytech event, what is the temperature of the beer that I'm keeping, and please don't let it go be below 68 degrees. Please don't let it go below 68 degrees. So it's a very important thing for me. But one of the great things about, and those who I would share this with, anything a computer can do, the Raspberry Pi can do. And so some fairly clever projects that I saw, one project was that a person put a facial recognition software and a camera on it, so that if you walked up to his tap and you pulled it, it activated the computer, it took a picture of your face, it calculated your tab, because there was a flow meter on it as well, so it knew how much you were taking, and if I lived in a house with lots of different beer drinkers, I would probably be interested in that. Again, it comes out of needs. It comes out of a place where you think about the things that you want to do. So what happens next? Where do we go from here? I'll be working with Truman College. We will be offering college credit courses for educators and out-of-school time providers. This is probably the single best thing that we can do. College credit is something that helps people advance in their careers. It is the sort of the currency of the city colleges of Chicago. And through this, we're actually going to be able to offer short classes in meaningful amounts of time so that teachers can come and learn these things in a very safe environment. Element 14 is going to continue to grow the STEM Academy and feature some very innovative work and continue to connect professionals with people who want to be professionals. Encourage the next generation of engineers. The IIT Boeing Scholars, they're actually going to be an integral part of this. Two of the STEM groups that she talked about are interested in looking at STEM education, are actually interested in working directly with students, and would probably be very happy to pick up Raspberry Pi or Arduino type projects to see what sort of artful projects students would like to participate in. It's a great thing to nucleate an out-of-school time or an after-school STEM club around. And overall, our partnership, you haven't heard the last of us. We're going to be reporting out and providing mentorship and anything to any curious parties. We made this work, and we're going to continue to make this work. And we definitely want to share our experiences with all of you. So with that in mind, we're relatively easy to get a hold of. Our email addresses are up here. We all have Twitter handles of some kind. I'm looking to break 100 this week, so please do follow. With that in mind, do you guys have any questions or anything you heard? Yes, sir.
You mentioned this student who had written what to do and not to do.
Yes.
In front of many educators.
Mm-hmm.
If you have access to that.
I do. I'd be happy to share it.
And it's on the STEM Academy.
It's on the STEM Academy.
He posted it in there. John Lewis Miller.
Yeah. One of the things that he put in there, maybe rather boldly, is just don't even bother with Scratch. He says, don't go with an analogy of what you're interested in learning. Go with what you want to learn. Just go right to Python. And he told a room full of people that. Any other questions? So we do have a Raspberry Pi up here if you guys want to come and check it out. Yeah?
Truman, are they the credits that they're offering, is that online or they have to?
We're able to offer both face-to-face and online courses. So we can do it either way. We're probably going to end up doing these in a hybrid format that is a blend of the two. So thank you guys very much for being with us this afternoon. I hope you guys have had a good time. If you want to come up and check out a Raspberry Pi with a LCD breakout plate on it, it's right there.